Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. Now, let's look at question 7, May June 2024 question paper, which is acid and base. Okay. So now we are told that a standard solution is prepared, by dissolving 10 grams of sodium carbonate. Here is that formula in 0.7 decimeter cubed, of water. Okay. So now calculate the uh, concentration of the solution. So we have the mass, we have the volume, we want concentration. Remember, we can combine this formula. Concentration is equal to N divided by V. With this formula, N it is equal to M divided by M. So can you see that we have this and we can find this? It's easy from your table. Then, and we want this, and we also have this. So can you see that here you can substitute in place of, like, you have this formula, man. You use this formula here. Okay. Sorry, man. I'm lying. Okay. This is the formula that you're gonna use. Then just substitute smoothly into it. What is your mass? Your mass is 10 grams. Then what is your molar mass? You'll just find your molar mass using your table there of what's that periodic table, which is something like your molar mass is 106 multiplied by your volume is 0.7. Then you get a concentration there of how much? You get a concentration of something like 0.13. 0.13 mole per decimeter cubed. No units, no mark. Okay, yes. Now, will the pH of the solution be greater than or less than 7? Now, sodium carbonate there, it is a weak base. Sodium carbonate, it is a weak base. So now remember, sodium carbonate, it is something like Ca plus and CO3 2 minus. Okay, so this is sodium plus and carbonate. So how do I know which one comes from what? This comes from sodium hydroxide. Okay, sodium comes from sodium hydroxide. Then this one comes from I've forgotten this acid, but yeah, something like H HCO3 2 minus, if I'm not mistaken, or just H2CO3. Yeah, I think something more or less like that. All right. Then now what happens? So we want to know if it's gonna produce a solution with a pH that is greater than or less than 7. Since when I told you this is a weak base, so now it means the pH now should be a basic, right? So it means if a solution is basic, it is greater than, right? But now we need appropriate equation to prove that. Write an equation that explains your answer. What you can do, you can say now, you take the one that comes from a stronger something, basically a weaker something. This is a strong base, this is a weak acid. So the one that comes from a weaker something, it is what? It is CO3 2 minus. It comes from a weaker acid. So you can take that CO3 2 minus and react it with what? With water. So it's gonna form something like, remember water, it is H plus OH minus. So the H plus will want to go there. So it will form something like HCO3 minus plus OH minus. So this is you proving that it gives us what? A basic solution. Okay. Another part that you can use, you can say now, you can take that sodium hydroxide, and not sodium hydroxide, sodium carbonate, and react it directly with water. Then you'll get the result of something like H2, okay, H2CO3 plus sodium hydroxide. Okay, Yes. So also here it gives you a result of sodium hydroxide thereof. Now let's move on. Uh, I'm told that the sodium carbonate solution is titrated with, okay, remember this is a weak base, is titrated with a dilute hydrochloric acid. Remember this is a strong acid. The following indicator are available for titration, range of that and that and that. The analogy that I use, it is Mary, baby, pack P. Okay, what do I mean by this strategy of take it with you? For methyl orange, it is a reaction what? For methyl orange, we use it when we use methyl orange in acid. Actually, let me say methyl orange in acid. Can you see methyl orange in acid turns red, but in base turns yellow. Okay. For B, which is bromothiamyl blue in acid turns yellow, but in base turns blue. Okay, then for uh, phenolphthalein here in acid, can you see all of them have A? In acid turns colorless, but in base turns pink. Okay, so the range here, it is pH that is less than 7. This is pH that is equal to 7. This is pH that is greater than 7. In this case, the indicator that is suitable, it is the one with pH that is less than 7, because what it is, this it is when we say we combine uh, uh, this is when we have a, okay, or strong acid plus weak base. Remember, a solution that is less than 7, it is acidic, right? Then here it is strong, or weak both. So here for pH that is greater than 7, it means it should be a strong base rather than weak acid. Okay, yes. Now, which one should we use here? Weak base and a strong acid. So it means the acid will dominate, meaning a pH should be less than 7. P is the correct answer. P is the correct answer. Why? Give a reason referring to the data thereof. You'll just say pH is less than 7. Okay. pH is less than 7, or it is a titration of a weak base and a strong acid. Then 7.2, when 0.01 moles, 0.01 moles of dilute sulfuric acid, this one, is mixed with 0.02 moles of potassium hydroxide in aqueous, the total volume of the final solution, it is 0.2 decimeter cubed. Now you should know between the two which one is in excess, which one it is a, a limiting. Okay, so what will happen is that I will have something like this. I will have something like this. So I will have potassium hydroxide. Let's say potassium hydroxide here plus H2SO4. Okay, H2SO4. Now I'm told that the final solution will have a volume of final solution of 0.2 decimeter cubed. But now we are interested in knowing which one between H2SO4 and H2SO4 and KOH, which one is the limiting reagent, which one is an excess. Now, how can we find that? We are told that this one, KOH, it is 0.024, and this one it is 0.01. Can you see now if this one it is in a ratio of 1:2? So if I use 0.01 moles of H2SO4, so it means it should translate to how many moles of KOH? Twice this, it is how much? 0.02. Okay, but can you see that this is in excess now? This is in excess, it has more than the required. Or I can also check using KOH. If I use 2 moles of KOH, which is 0.024, for H2SO4, I will need 0.012. Can you see that it is more than what it has? So now, we now know that this is a limiting reagent, this is in excess. So now when you calculate pH, we find pH from the excess, okay? pH, we'll find it from the concentration of the excess one. So now we know that in excess, after the reaction has occurred, what will be left here, this was before, after, after the reaction, what will happen is that the concentration there, or rather what will be left, it will be KOH here. So only KOH will be left here. Why? Because H2SO4 is the limiting reagent, it will be used up. And now it will be in a volume of 0.2 decimeter cube. Okay? And now there will be only a hydroxide ions here. So it means when we want our pH, we will be using our hydronium ions to find the what? To find the pH. Now, how can we do these calculations? Now, let's try to find the concentration of KOH. Okay, that is in excess. Okay, how can I do that? The first thing first, I should tell the examiner that I'm giving the initial. Remember, how can I find? I calculate. How can I calculate the number of moles of this in excess? Remember, if you have excess and limiting reagent, it means now this one should have amount that has reacted and it has an initial. So if you say initial minus the reacted, you get the what? The excess. Okay, because it is the initial one minus the one that has reacted. It will give us the rest, the remainder. Okay, now let me try to remove this. So now that I know that H2SO4 is a limiting reagent, so it means now I will find the reacted number of moles of KOH using it. So I'll say the number of moles of KOH that reacted, please take note of that, that reacted will be equal to the number of moles, or not necessarily only the number of moles, what twice, it will be twice that. Okay, it will be twice. Why? Because it is in a ratio of 1 is to 2. Or let me just do this, the ratio it is 2 is to 1. Then here, oh, what are we dealing with? KOH is to H2SO4. The ratio is 2 is to 1. We are trying to find the number of moles of this one that has reacted. So we're going to use what? The number of moles of this, which is 0.01. So when you do your mathematical gymnastics, you'll get number of moles of KOH that has reacted. It is equal to 0.02 moles. But now I can find the number of moles that are in excess. Number of moles of KOH in excess, you'll say it is the number of moles of KOH that were there initially minus the number of moles of KOH that did what? That reacted. So initially it had 0.024 minus 0.02. So it gives us something like 0.004 moles. But now those moles there are these moles here. Okay? Are these moles here where we have KOH here with a volume of 0.2 decimeter cube. But now inside here there will be floating K plus as well as OH minus. So if you want to find, so and the concentration of KOH is still the same as the concentration of OH. Okay, similarly the number of moles of KOH are equal to the number of moles of OH. Okay, because they are in a ratio of 1 is to 1. Okay, then now I can say, how about I find the concentration of OH minus, which is the same as, okay, let me say, how about I find rather the concentration of KOH, which is equal to the concentration of OH minus. C is equal to N divided by V, right? What are number of moles? My number of moles in this case, remember I'm using excess. I'm going to use excess. Okay? I've forgotten the spelling of excess. The spelling is gone. But yeah, excess, something like that. So the volume of the remainder. So every time when you want concentration of hydronium ions or hydroxide ions, you use the excess. So it is 0.004 divided by 0.2, which is something like 0.02. Let me just confirm that in my calculator. I don't know why. I do not believe this. Okay, 0.02. Okay. So what? This is the concentration mole per decimeter cubed. Now that I have concentration of this one excess, remember I want the what? The pH. And remember pH formula, it is pH, it is equal to negative log of hydroxide ions, like that. But I know I can get, I also have this formula that say POH plus pH, it is equal to 14. So why can I not find POH, then subtract it from 14? Can you see that? So POH formula goes like this. POH, it is equal to negative log of OH instead of H plus. The difference between pH is that it uses H plus or H3O plus, but for POH it uses what? Negative log. So it's gonna be negative log of how much? 0.02. Okay, okay, then you get something like a concentration of something like 1.7. 1.7. Okay, so this is POH, but now we are interested in what? In pH. So we're gonna say pH plus POH, it is equal to 14. Therefore it means pH, it is equal to 14 minus 1.7, which is something like 12.3. Okay, yes, yes, that's how you are supposed to go about that one. Okay, or someone from this step, instead of finding POH and what, someone might say, okay, let me find, I know that concentration of H3O plus multiplied by the concentration of OH minus, according to my formula there, it is 10 times, 1 times 10 to the power of negative 14. It's still the same, 1 times 10 to the power of negative 14. And I know I wanted the concentration of H3O plus to help me find the pH. What is the concentration of OH minus? Concentration of OH minus, when I substitute, I use the round bracket, it is 0.02. It is equal to 1 times 10 to the power of negative 14. When I divide there, I get the concentration of H3O plus as something like 5 times 10 to the power of negative 13 mole per decimeter cubed. Then I can come to my pH formula. pH, it is equal to negative log of my hydronium ions. Therefore, it is negative log of, then I substitute whatever that I got, which is 5 times 10 to the power of negative 13. Then I get something of an answer like 1.23. So 12.23. 12.3. Hey. So yeah, that's how you're supposed. You can also calculate using concentration. That's fine. Okay. So that's all from us. And question 7, which is acid and base. I hope you enjoyed it. So let's meet on the last two questions, which is electromagnetic. So electrolytic cells. Okay. Electrochemistry. Thank you. If you see any mistake, please leave it in the comment section. Thank you.